vectors lecture 1. I'm sure you have understood where to find it. If you haven't, please ask me again after class. I'll show you where we can find it. And we essentially covered the first 10 pages in the previous class. Um, what Let me revise. Achha, my voice isn't clear. Is it not clear for everyone? Hello, check. Is it? It seems like it's clear for everyone. So जिसके लिए clear नहीं है, just try and see what you can do. Maybe just disconnect and reconnect to the audio, and try using headphones. Okay. Normally ऐसा होता है कि if you get a call in the middle of your Zoom meeting and you cut the call वगैरह, उसके बाद suddenly the voice level drops. So you may have to reconnect to your audio in that case, not to the meeting, just the audio. Okay. So I would say, please, all those students joining new, just go through the previous lecture and you can cover up easily. Okay, 1 to 6. There's nothing you need for today. I'll just cover up these points from page 7 onwards. We may need that today. So we are in vectors. You can see in detail what I taught in the previous batch, but to put it, just to summarize, vectors is used for, in simple words, is used for quantities, है ना, जिनका मैग्नीट्यूड भी होता है और डायरेक्शन भी होता है. और मैग्नीट्यूड क्या होता है? मैग्नीट्यूड इज basically it asks the question how much, how for instance, if I say I have applied a force on someone and the question comes up, kitna force apply kiya. So magnitude answers the question kitna force applied kiya. Okay? I know we guys have done page 7. I'm just quickly revising for the few students who have joined new. Okay? And then we'll move on. So I'm not revising the first 6 pages. Detailed revision नहीं है, quick revision करके हम आगे बढ़ रहे हैं. ठीक है? So कितना apply किया? That is magnitude. So 5 Newton is your magnitude. किस direction में apply किया? That is your direction of the vector. So this seems to be 5 Newton towards the right. This seems to be 10 Newton, that kind of direction. And how do we represent vectors? We typically represent them by drawing arrows. Okay? And arrow के सामने हम magnitude लिखते हैं. Arrow तो naturally direction दे देता है ना? The arrow is pointing in the direction of a vector. But on top of that, we try to keep the length of the arrow proportional to the magnitude of the vector. ठीक है? जितना ज्यादा magnitude होगा उतना बड़ा length use करेंगे. Theoretically, तुम्हें scale use करके draw नहीं करना पड़ेगा, but theoretically this is what you have to do. So if I draw a 5 Newton vector 2 centimeter long, then I'll draw a 10 Newton vector 4 centimeters long. Okay, 4 centimeters long. That's the idea. And एक second, one guy is struggling to join. And फिर if I want to represent a vector which is going into the plane, so if I imagine I'm pressing my screen right now. So as I'm pressing my screen, I'm pushing my screen. And if I want to draw the force with which I push my screen, so we represent that force, that inward going force, we represent that direction with this symbol, with an X and a circle around it. And iska logic kya hai? Since we are representing vectors with arrows, you might have seen in cartoons that when an arrow flies away from you, पीछे से देखोगे तो you'll get to see the tail of the arrow, which looks like an X, right? Because of the feathers at the tail of the arrow. So this represents an arrow going away from you. Therefore, this represents a force. In this case, force मैंने है ना? I'm talking about a force. So this represents a force of 3 Newton going away from us. Okay? On the other hand, if you see a bird flying towards you, how will you represent that vector? If you see, like you're watching a 3D movie, something is coming out of the screen. How do you represent that vector coming out of the screen and towards you? So if you want to represent a vector coming towards you, perpendicular to the plane of the screen, perpendicular to the plane of your notebook, then what you'll have to do is you'll have to draw a symbol like this, a circle with a dot around it, because the dot represents the tip of the arrow. Okay, and like if an arrow were to come towards you, what you would typically see is the dot, the tip of the arrow. Okay, um, that's it. I'll just maybe go over the symbols as well. No, so एक बार symbols दिखा देता हूँ. I can understand what you've asked. So symbols, we represent vectors by any alphabet, X, Y, Z, Greek alphabet भी चलेगा, theta वगैरह. ठीक है, we represent them by any alphabet. But एक specific point होता है कि we either put a special symbol over it. Okay, so the special symbol is called a bar. That bar can look like a straight line. Okay, it can look like a straight line, or it can look like an arrow, you know, or it can look like a fish hook. That all doesn't matter. Those are just fancy symbols which people will use if they have access to those symbols. And sometimes when the printing publication does not have access to placing those symbols, they simply use bold. They simply use bold. So one of these two symbols represents a vector, and one of you is asking, does the arrow over here represent anything? No, this doesn't cover direction. तुम सोचो ना, मतलब मुझे अगर ऐसा 5 Newton vector draw करना होता तो would I draw something like this? बिल्कुल नहीं. Okay, this is just a symbol. Whether I draw a bar or I draw a bar with an arrow like that, it's just a symbol. Okay, that symbol does not, the direction of the arrow on top of the symbol does not give you any direction of the vector. It's just a symbol. It's just telling you that this quantity A is a vector quantity. Okay, so that's how you represent a vector. Is that enough? The new students, did you get that? अब इसमें एक और चीज, लास्ट चीज बोलना था. जैसे हमें पता है कि if you look at this example, मुझे पता है कि वेक्टर को हम मैग्नीट्यूड और डायरेक्शन से रिप्रेजेंट करते हैं, है ना? Any quantity which has magnitude and direction could be a vector. There's a little bit more to that definition, but you will cover that up when you watch the recording. But यहाँ पे A bar represents 5 Newton towards the right, let's say. ठीक है, this is just an example. अगर मुझे सिर्फ मैग्नीट्यूड के बारे में बात करना है, then I can talk about the magnitude in two ways. One is I could remove the bar and then I'll automatically talk about the magnitude. And the second is I can place a mod symbol around it and I'll automatically talk about the magnitude. Okay, so that's how you talk about the magnitude. What you need to do is you either, that's what these statements are trying to say. Okay? You can read them after class. We did this last time, but the idea is vector का मैग्नीट्यूड के बारे में बात करने के लिए तुम या तो बार हटा दो, सिर्फ ए लिख लो, तो ऑटोमेटिकली यू आर टॉकिंग ओनली अबाउट द मैग्नीट्यूड, या ऐसा एक मॉड सिंबल डाल दो. Okay, so these two vertical lines placed on either side of A bar, okay, that's read as mod A bar. Mod sign डालोगे तभी भी we remove the direction and only talk about the magnitude. Okay, यहाँ पे भी same चीज देख लो. Imagine I have drawn this in bold and I'm representing this particular vector 3 meters per second upward. I only want to talk about the magnitude. So what I'll do, the symbol that made this a vector, the bold symbol, I'll remove the bold and I'll write a normal A. So that normal A will automatically talk about the magnitude. Okay. And then similarly, mod of that vector symbol, mod of A bold, will also talk about the magnitude. या तो mod symbol डाल दो to talk about magnitude, या वो vector symbol हटा दो, तो vector symbol था bar या bold, वो हटा दो, you'll automatically talk about the magnitude. Okay, so those were two things I felt was necessary to just revise for the new students before proceeding. This does not cover everything we did in the first lecture. Okay, so I want you to watch the lecture recording all the new students, I think there are 10, 12 new students, please watch the lecture recording, and please, yeah, as I said, this is a new chapter. This is vectors. So as you watch the lecture recording, if you want to make notes, please make notes. We have essentially covered up the first 10 pages of my notes. Okay. And making notes, just to repeat, that's an option. तुम्हें बनाना है खुद के notes, बना लो. तुम्हें नहीं बनाना है, if you just want to refer to the notes that I've already uploaded on the drive, okay, which is basically this, what I'm showing you guys right now. You just want to refer to this, that's also fine. Ultimately, we'll, once थोड़ा और theory cover हो जाएगा, we'll start solving questions. Ultimately, solving questions is all you need to understand the chapter. Okay? All right, so with that, we'll proceed. If you have any doubts, just type out the doubts. So we don't typically allow you guys to to unmute and ask it out. This is just for safety's sake, because sometimes spammers enter these meetings and then they cause problems. But you can type out your doubt and I'll immediately respond. Kuch bhi doubt hai, type it out, immediately respond. Okay? Even if you feel I mentioned this before, that's all right. You can just type and ask. All right. So with that, what we're now going to do is we're going to multiply vectors with scalars. Okay. And for the first part, on this page, we're going to look at how we can multiply a vector with a positive scalar. Positive scalar. So a scalar is a normal quantity which does not typically carry a direction with it. Okay? So for instance, a number can be a scalar. 2 apples, so 2 can be a scalar. Yeah, 2 seconds, time can be a scalar. Okay? You'll get to see more examples of scalars when you see the recording. But now the result, so when I multiply a vector with a positive scalar, the result is still a vector. Okay. So what do I get? First thing is I get a vector quantity. Second thing is the direction stays the same. ये वेक्टर का जो भी डायरेक्शन था वो ही रिजल्टेंट का भी मतलब इसको मल्टीप्लाई करने के बाद वही डायरेक्शन रहेगा. तो मल्टीप्लाई करने के बाद वेक्टर रहेगा, डायरेक्शन सेम रहेगा. फर्क बस क्या आएगा कि वेक्टर का मैग्नीट्यूड विल गेट मल्टीप्लाइड विद द मैग्नीट्यूड ऑफ द स्केलर. The vector का magnitude will get multiplied with the scalar. That's it. So very simple demonstration. ये देख लो, a bar अगर 3 Newton towards right है, तो 2a bar is first of all still going to be a vector. It's going to still have the same direction. The only difference is 2a bar का magnitude is going to be 2 times a bar का magnitude. तो a bar का magnitude 3 Newton था, 2a bar का magnitude is going to be 2 times 3 Newton. So 2 just gets multiplied with the magnitude of your vector. है ना? Makes sense. Double of a bar should be 6 Newton. Double your force बोलेंगे तो तुम double force लगाओगे same direction में, है ना? वही फंडा है. Whenever you multiply a vector with any number, the magnitude gets affected. The magnitude gets multiplied with that number. Got it? Okay. And for the new students, if you can see, I've drawn this arrow twice as big because, roughly twice as big, because the logic is this कि जितना magnitude है उतना arrow का size रखना है. Theoretically. Exactly करने का जरूरत नहीं, but theoretically. So since I've doubled my magnitude, I've also doubled the size of the arrow, theoretically. Okay. And a bar by 3, similarly, अगर मैं divide करूंगा, if I divide a vector by a number, what do I get? The same logic है, because actually division by 3 is like multiplication by 1 by 3. Dividing by 3 is like multiplying with 1 by 3. Okay? So a bar by 3, yeah, a bar into 1 by 3 is ultimately going to be what? still going to be a vector, still the same direction. Only difference is 3 Newton gets multiplied by 1 by 3. Yeah, 3 Newton gets divided by 3. So what am I left with? 1 by 3 into 3 Newton. I'm left with a vector of magnitude 1 Newton. Simple, eh? So whenever I multiply this with a positive number, direction stays the same. Yes, whenever I multiply with any number, direction stays the same. Only the magnitude gets multiplied or divided by that number. Okay, तो यहाँ पे I'm saying कि अगर मैं a बार को 3 से डिवाइड करूंगा तुम डायरेक्टली भी कर लो, ऐसा मतलब ऐसा नहीं है कि you have to imagine that as multiplication with 1 by 3 and only then solve. 3 न्यूटन ऊपर दिख रहा है, a बार में 3 न्यूटन दिख रहा है, डिवाइड बाय 3 करोगे तो कर दो 3 by 3 1, नो प्रॉब्लम ओवर देयर. 3 by 3 1 न्यूटन कर दो, है ना, no problem over there. You can do it directly as well. You can directly divide. यहाँ पे I'm just saying कि why this is still under the same heading. Means एक बार मैंने बोल दिया कि ये multiplication के लिए true है. I don't need to separately teach you division because dividing by 3 is like multiplying with 1 by 3. So it's one and the same. If you know the rule for multiplication, इसमें division gets covered. Dividing by 3 is like multiplying with 1 by 3. Okay, so whichever way you want to see it, या तो देखो as 3 into 1 by 3 या 3 divided by 3, this should be your answer. यहाँ पे convinced, got the idea. It's a very simple thing that we're talking about. Only the magnitude gets affected. Any doubts over here? One of you saying, can vectors and scalars be added? No, vectors and scalars cannot be added. Vectors and scalars cannot be added. That's quite logical. I mean, imagine you can only add things which are the same. I mean, I can add two forces, but does it make any sense to add force and time? Makes no sense. Yeah, it makes no sense to add force and time. So therefore you'll never add vectors as such. Any other doubt on this page? समझ में आ गया? Okay, let me know if you're done writing. In the sense, if anyone is still writing, just say wait. I'll wait. Otherwise, I'll move on to the next page. Thanks. Done? Okay. All right. Thanks. Now, the next thing we're going to see is negative of a vector. Negative of a vector. Matlab, if I have a vector a bar and I know what a bar is, what on earth is minus a bar going to be? Think what is the negative of a vector? So the idea is it is a vector of the same magnitude. So does this rule apply to division as well? So if you're asking about this, then answer is yes. I mean, that was the purpose of this last example. Like over here, I'm dividing a vector by a scalar, and I'm telling you it's essentially the same rule because division by a number, like for instance, division by 3 is multiplication with 1 by 3. So you can imagine it as multiplication with 1 by 3 and then 1 by 3 into magnitude gives me 1 Newton. All right. So since it works for multiplication, it also works for division. Finally, end result क्या हो रहा है? ऐसा ही result हो रहा है कि तुम a bar की magnitude को 3 से divide कर रहे हो, है ना? So if you divide, on that note, if you divide a vector by any number, the magnitude gets divided by that number. The magnitude gets divided by that number. Got it? A bar by 2 would be 1.5 Newton. Got it? Clear? No one who asked that doubt. Let me know. Let me know if your doubt got clear, okay? Negative of a vector. All right, thanks. It is a vector of the same magnitude, but in the opposite direction. Yes, I think somebody was trying to say this. Very nice. Negative of a vector is a vector of the same magnitude, but in the opposite direction. That's it. Vector of the same magnitude, but in the opposite direction. क्या लॉजिक है इसका? Imagine this. Imagine I say कि okay, I'll just erase that by mistake and it's back. Imagine I say कि there is a vector a bar which is describing some kind of displacement for me. So it's telling me कि so and so person went 3 meters towards the right. Okay, somebody went 3 meters towards the right. And if I want to talk about minus a bar, so by the logic we saw in the previous result, ki if I multiply this with some number, the magnitude gets multiplied. So right now I'm multiplying this with -1. So well, theoretically my magnitude should get multiplied by -1. And all of a sudden I am getting something like this. I am getting ki minus a bar is apparently -3 meters towards the right. Now what does that mean? If I tell you somebody went -3 meters towards the right, what does that really mean? So moving towards the right by -3 meters actually means, instead of moving towards the right, it means moving towards the left by 3 meters. Yes, right? So आगे -3 meters जाना मतलब पीछे 3 meters जाना. आगे -3 meters जाना मतलब पीछे 3 meters जाना. So -3 meters towards the right is actually 3 meters towards the left. -3 meters towards the right is actually 3 meters towards the left. So what have we got over here? Minus a bar is very similar to a bar. In fact, it has the same magnitude as a bar. The only difference is that the direction got reversed. So a minus sign only reverses the direction. It just makes the direction opposite and nothing else. That's what a minus sign does. It just makes the direction opposite. It just reverses the direction. Okay. Minus a bar is this. Okay, and just be clear, minus a bar is not this. ये बस मैंने तुम्हें this is just an intermediate step to help you imagine minus a bar कैसे ये निकल के आता है. Okay, at the end of the day, this is minus a bar. A vector never has negative magnitude. Okay, although you understood when I said -3 meters towards the right क्या है, although you understood it meant 3 meters towards the left, but that said, henceforth we will never talk in that weird way कि कोई -3 meters इधर जा रहा है, -2 meters उधर जा रहा है. That sounds weird. We'll always tell you some positive magnitude and the direction. Directly बोलेंगे 3 meters left की तरफ जा रहा है. So vector always, therefore, has positive magnitude. Okay, and one of you saying, sir, if we have changed, अब कोई बोल रहा है, एक मिनट, I'll address your doubts. So one of your doubts is, so if we change the direction, shouldn't the minus sign also be removed? तो निकाल दिया ना मैंने, यहाँ पे निकाल दिया. I have changed the direction और यहाँ से minus sign हट गया. क्यों निकालेंगे ए से? मतलब फिर तो प्रॉब्लम आ गया ना. हाउ आर यू सेइंग कि ए इज minus sign यहाँ भी हटा दिया, then you are saying कि a bar is 3 meters towards right. You're also saying a bar is 3 meters towards left. Makes no sense, na? A bar is 3 meters towards right. Uska negative. यहाँ पे there's no reason. I have not done anything to make the minus disappear. यहाँ पे I have done something to make the minus disappear. I have changed the direction. Left hand side पे minus sign रहेगा ही. ठीक है? And the other one is asking, sir, is the left hand side always negative? I don't know what you imagine by that. Is left, this is just a symbol. So minus a bar is a symbol. That doesn't mean a bar ज़्यादा positive है, minus a bar ज़्यादा negative है. If you look at what they represent, they actually represent two vectors with positive magnitude only. One is 3 meters towards right, one is 3 meters towards left. Minus a bar is यहाँ पे for vectors, minus is just a way of saying opposite. Okay, so minus is just a way of saying opposite. So you'll have to imagine it as that, not as a negative vector as such. You can say it is negative of a bar, that's fine, but don't visualize it as a negative number and this guy as a positive number. They both have positive magnitudes always. It's only what the minus sign does is it tells you the direction is opposite. So it's a way of changing the direction, flipping the direction around. Okay. And another doubt was we never use minus sign while writing vectors. I think your doubt is this. To be more specific, you meant we never use minus sign while writing the magnitude of a vector. Is that what you meant? Because I clearly use a Yes, vector ka magnitude is always positive. Okay, it's ridiculous to say कि I have applied a force of -2 Newton. सीधी सी बात कर लो. I have applied a force of 2 Newton in which direction? Specify the correct direction. So vectors का magnitude is never negative. ये बस just to break it down मैंने किया. Ultimately, this is minus a bar. Okay. Does opposite always mean left direction? No. Yeah, opposite just means opposite. If I say 2 Newton upward, if I say this is B bar, then minus B bar will be 2 Newton downward. Yeah, but downward. Minus sign just changes the direction. Okay. यहाँ पे नीचे मैंने क्या लिखा? यहाँ पे remember mod means magnitude. So I'm saying magnitude of the A bar vector and magnitude of the minus A bar vector. Both those magnitudes are the same. Both those magnitudes are 3 meters. Okay, the mod sign means magnitude. Yes, mod of minus. So magnitude of A bar is 3 meters and magnitude of minus A bar is also 3 meters. Okay, they are both 3 meters because magnitude never has the minus sign. So whenever you find any vector, even if it's minus A bar, वो वेक्टर के आंसर में तुम्हें माइनस साइन नहीं दिखेगा. You have to remove that minus sign and change the direction. आंसर में माइनस साइन नहीं दिखेगा. Ultimately ये है, minus of a vector just changes the direction. Just remember that. Nowhere there is a minus sign in the value of that vector. It's some positive magnitude along some direction. Okay? Did that clear everyone's doubt? Okay. Yes, you have to remove the minus sign. Minus sign डालना ही नहीं है. Minus sign डालना ही नहीं है इसमें, बस direction उल्टा करना है. I ask you to take the negative, बस direction उल्टा करना. Okay? All right. So that was negative of a vector. Let me know if you're done with this page. Wait बोलना तो wait बोल दो. So now let's put the two together. We have seen what happens if I multiply a vector with a positive number. What will happen if I multiply a vector with a negative number? Okay, so this is simple. Just combine page 11 and page 12. If I multiply a vector with a negative number, I still get a vector. The negative sign makes the direction the opposite of what it was before. And a negative sign changes the direction. And magnitude simply gets multiplied with the magnitude of the scalar. मतलब इसका मतलब क्या है? एक बार देखते हैं. तो जैसे अगर तुम्हें पता है कि a bar है 3 meters towards right, -2 a bar क्या हो जाएगा? तो -2 a bar, एक तो the minus sign will first change the direction. तो direction right की जगह left हो गया, उल्टा हो गया. The second thing is the 2 will get multiplied with 3 meters. like we saw before. So 2 into 3 meters will make it 6 meters. Got it? Simple. So a bar is 3 meters towards right. वैसा ही minus 2a bar is going to be 6 meters towards the left. माइनस साइन की जगह के कारण डायरेक्शन चेंज हो गया, 2 के कारण मैग्नीट्यूड डबल हुआ. Okay, good. And your question is why we did minus 2a bar. ये एग्जाम्पल दे रहा हूं, मैंने इतना दिया एंड मैं दे रहा हूं कि minus 2a bar फिर क्या होगा. These are examples. So minus 2, when a bar is 3, minus 2a bar will be 6 meters towards the left. Minus a bar by 3, what will that be? तो माइनस साइन पहले क्या करेगा, इसका डायरेक्शन को उल्टा करेगा, एंड ए बार बाई 3 मतलब मैग्नीट्यूड को तुम 3 से डिवाइड कर लो, तो 3 मीटर का 3 मीटर डिवाइडेड बाई 3 विल गिव मी 1 मीटर. So minus a bar by 3 becomes 1 meter towards the left. These are random examples, but you're getting it. क्या हो रहा है? Minus 5a bar. दिख रहा है कैसे? minus 5a bar. पहले माइनस साइन के कारण डायरेक्शन को उल्टा करोगे एंड फिर मैग्नीट्यूड को 5 से मल्टीप्लाई करोगे तो 3 मीटर 15 मीटर हो जाएगा. Got that? Yeah, quite simple. What is minus a bar by 6? Yeah, simple, very nice. Minus by 6, huh? This is divided by 6, divided by 6. Minus a bar divided by 6. The minus sign changes the direction. Right becomes left, right? Right becomes left, and then the magnitude gets divided by 6. So 3 meters by 6 is 1 by 2. Very nice. 0.5 meters towards left. 3 by 6, 1 by 2 meters. Okay, let me know if you're done with this page. If you're not done, say wait. Yeah, that's simple. Multiplication. Okay, I'll wait. Yeah. Multiplication with a vector is really, really simple. Sorry, multiplication of a vector with a number is really simple. With a scalar is really simple. All right, thanks. Welcome. Now, the next term we're going to look at is zero vector or null vector. Yeah, zero vector or null vector, they are synonyms. They refer to the same term. This is a vector having zero magnitude and no specific direction. ये हो गया ये वेक्टर का डेफिनेशन. दिस इज अ वेक्टर हैविंग जीरो मैग्नीट्यूड, मतलब मैग्नीट्यूड ही नहीं है ना. 0 न्यूटन का फोर्स डाल दो, ऐसा किसी ने बोला 0 न्यूटन का फोर्स डालो. So it has zero magnitude, and then does it make a sense? Does it make any sense to talk about its direction? It does not. If I'm telling you to apply a 0 Newton force, it does not matter which direction I tell you to apply it in. In all cases, it's going to make no difference because you're going to apply 0 Newton force. So vector having zero magnitude and no specific direction, or just an arbitrary direction. Arbitrary means random. That vector is called your zero vector. Okay. Now, let me explain why we are calling this a zero vector. I know, isn't 0, 0. Why should I talk about 0 as a scalar? And why should I talk about 0 as a vector? So this is the reason, although it is uh, having no magnitude, so is as good as nothing, why do we still continue to call it a vector? Let me explain that. So the idea is ki imagine this. Imagine I'm adding two vectors and getting a third vector. I'm adding vector A to vector B and I'm getting vector C. Now the idea is ki vector plus vector should always be a vector. Does that make sense? If I add two forces, I'll get force. है ना, force plus force add करके मुझे है ना time नहीं निकल के आएगा, है ना, force ही रहेगा. So adding forces, adding vectors gives me a vector. If I were to add these two vectors, a bar and minus a bar, if I were to add these two vectors, I should still get a vector. But logically, what will I get if I add a and minus a? I should get 0. But is this 0 the number 0? Or should it still be like a vector? Because I can't add two vectors and get a number. I can't add two vectors and get a scalar. I'm adding two vectors and I should still get a vector. But what I'm getting is 0. So therefore, we have defined this term 0 vector, because when I add a and minus a, what I get needs to have 0 magnitude, but what I get needs to be a vector quantity. Hence, we have defined the term 0 vector. Okay, so that's how it's a vector. It's a combination of two vector quantities. For instance, yeah, what does arbitrary direction mean? Arbitrary direction means random direction. Random direction. ये एक example देख लो. If you remember, we started our class with this example. If I have started a class, started last week's lecture with this example. Imagine two people are pushing a car. One person is pushing the car towards the right with the force of 2 Newton. Another person is pushing the car towards the left with a force of 2 Newton. If you combine the two forces, if you combine the forces together, you expect to still get a force. You expect to still get a vector. Why? Because force plus force is always a force, right? So you expect to still get a vector, but what are you expecting to get? You're expecting to get 0 Newton. If two people are gonna like foolishly push like this in opposite directions, what are you gonna get? Their efforts are gonna cancel out. Okay, it's as good as applying 0 Newton force. So the resultant is coming out to be 0 Newton. Now, can we really talk about the direction of this force? Can we argue कि the direction ये 0 Newton right की तरफ ही है या 0 Newton left की तरफ ही है? Or is it that the direction does not matter at all? It seems like the direction does not matter. It does not matter. As long as we know it's a force, and as we know it should be a force, and as long as we know that this is um, ultimately 0, I mean the forces have cancelled out, that's more than enough. The direction does not matter. Because the direction does not matter, we say that the direction, there's no specific direction that a 0 vector has. There's no specific direction, and therefore the direction is random or arbitrary. Arbitrary means random. या डायरेक्शन से फर्क नहीं पड़ता है. तो नॉट अ कॉम्प्लेक्स टर्म. इस पे मतलब ऐसा कुछ कॉम्प्लेक्स नहीं है. बस 0 जो वेक्टर होना चाहिए, whenever a vector has to be 0, we call that a 0 vector. Whenever a vector has to be 0, we call it a 0 vector. ठीक है. फोर्स कट कट के 0 हो गया तो है ना, when we say force is 0 Newton, that 0 is not the number 0. It's 0 Newton. It should be a force which is 0. So it's a 0 vector. Okay? Clear? You can't use this in solving questions and all. I mean, this is just a theoretical term. You should know what 0 vector means. Okay. Let me know if you want me to wait on this page. Yeah. All right. The next idea is equality of vectors. Again, just a theoretical idea. Let's go over this quickly. Vectors are said to be equal if their magnitude and their directions are the same. Logical hai na? Imagine if one person is pushing the car with a force of 2 Newton towards the right, and somebody has gone under the car and he's trying to lift the car and he's applying a force of 2 Newton upward. Can we really say the two forces are the same? I can't really say the two. We can't really say they're doing the same thing. They may be applying the same magnitude. The strength of the force they're applying may be the same, but they're not applying these same vectors because the directions are different. So A bar and B bar are not going to be considered to be the same vector. A bar and B bar are not considered as the same vector. Okay. A bar, B bar are not considered as the same vector. Um, okay, anyways. So they are not considered the same vector. Similarly, A bar and C bar are not considered the same vector. Why? Because direction same है पर magnitude अलग है. So when will a vector be considered to be the same? A vector will be considered to be the same if it has the same magnitude and the same direction. Now imagine, try and see what is that telling me. Matlab where I am drawing A bar doesn't seem to matter. I drew it over here, I drew it over here. Where I'm drawing it doesn't seem to matter. I can draw it over here again. I can draw it over here again. I can draw it over here again. Vector को किधर भी draw कर लो, फर्क पड़ नहीं रहा है. It is still apparently the same vector. Why? Because all that needs to be the same is the fact that they have the same magnitude and the fact that they have the same direction. As long as that is the same, I can really move my vector around and it's still going to be the same vector. It's still going to be the same vector. Okay, it's still going to be the same vector. One of you is asking, are all zero vectors the same? Zero vector may, since we don't talk about the direction, we'll just say that all zero vectors are the same because the magnitudes are the same. ये डायरेक्शन का ज्यादा फर्क नहीं पड़ता है. मैग्नीट्यूड सेम है, सब जीरो है, तो जीरो सारे जीरो वेक्टर्स को सेम बोलेंगे लॉजिकली, है ना. जीरो ही है और क्या है. यहाँ पे if I draw new vector, I give it the name d bar, and it so happens कि d bar has the same magnitude and d bar has the same direction as a bar. What will we conclude? We'll conclude and say कि a bar is equal to d bar. Okay, so that's the idea for equality. But now this idea leads us to something very important. It tells us that this particular vector can be moved around. This particular vector can be moved around without changing the vector. Can you see that? इसको मैं इधर उधर ले रहा हूँ, but wherever I take this vector, it still has the same magnitude. It still is pointing towards the right, मतलब it has the same direction. और इसको किधर भी जाके प्लेस करूंगा, हर जगह इसका magnitude and direction same रहेगा. मतलब this vector is not changing. In other words, if you can read this sentence over here नीचे, okay, I'm trying to just show it. A vector can be moved parallel to itself. Now what does parallel to itself mean? It can be moved without rotating it. And if you move a vector without any rotation, you do not change the vector. So you can move a vector parallel to itself without changing the vector. So what I'm doing right now, I'm moving this guy parallel to itself. As you can see, I'm not rotating it. If I were to rotate it, it will become like B. If I were to rotate it, the direction would change and the vector would change. But if I move it around and place it somewhere else without rotating it, if I move it like that, I'm basically moving it parallel to itself. The lines, as you can see, they always stay parallel. So if I move it parallel to itself without any rotation, then the point is I do not change the vector. So I'm allowed to move it like this without changing the vector. I'm allowed to move it like this and I can still call it a bar. Understood? ये जो motion होता है moving without rotating, that motion has a name and that motion is called as translation. Okay, this is not the translation की English को हिंदी, हिंदी को English, वो translation नहीं. This motion is called as translation. It's an important term describing two possible types of motion. एक होता है घुमाना. तो rotation तुम imagine कर सकते हो. If this arrow starts rotating like the needle of a clock, then it's rotation. है ना? ऐसा घूम अगर ये if it starts pointing down, then towards the left, then upwards. If it starts rotating like the needle of a clock, I can't demonstrate that in this app, but you can imagine that. Then that would be rotation. Rotation मतलब घूमना. And translation मतलब इधर उधर move करना बिना घूमना. Moving without rotating is translation. Moving parallel to itself without changing the direction and without changing the orientation is translation. Okay, is you got that? Now one of you is asking is, come on, undo symbol. One of you is asking, is linear and translation the same? Okay, so yeah, actually a lot of people get confused. I don't know where they pick it up from, but translational does not mean straight line motion. Okay, linear, yes, and a linear would mean along a line. The straight line motion अलग चीज है and translation अलग चीज है. Let me give you an example. For instance, what kind of motion? Think carefully. If I were to talk about a giant wheel, you've all sat in you've seen a giant wheel at least in your life, है ना? So imagine the motion of a giant wheel. ठीक है, ऐसा घूम के आता है. Would you call this linear? Would you call this rotation? Imagine the motion of the cabin in which you sit. Will you call that motion of the cabin linear? Will you call it circular motion? Sorry, will you call it linear? Will you call it rotation? Will you call it translation? The motion of a Ferris wheel, is it linear? Is it rotational? Or is it translation? Wow, very nice. Good. Okay. Majority are saying translation. Some are saying rotation. One said linear. So please understand, linear means straight line. This is definitely not motion along a straight line. So linear is out of the window. Yeah, very nice, Neha. Say linear is out of the window because this is not motion along a straight line. Now you can think this is rotation, by thinking कि घूम रहा है, गोल घूम रहा है. But if you actually analyze carefully, this moves along a circular path, but the cabin itself never really rotates, right? If the cabin were to rotate, you will fall out of the cabin when you reach the top. The cabin is always facing upward. Cabin is always facing upward. It never really rotates. So if that's you in the cabin, I mean, your head is always going to be up. It never really rotates. So this kind of motion where the cabin is basically just rotating without changing, it's going along a circle and is not changing the orientation. That kind of motion is called as translation. What's really going on is, no matter what happens, it's going along a circular path. The path is not a straight line, but can you see ki this is effectively moving parallel to itself? Right? So all those who said rotational earlier, can you now see why this is actually translation? Because what is up stays up, what is down stays down. There is no rotating like a clock. I mean, there's no change in orientation. That's the best word. There's no change in orientation. Okay? What's up stays up. So that is translation. So get this in your head. Translation is not straight line. Translation can be along a zigzag curve. Translation can be along a circle as well, like in a Ferris wheel. It does not have to be a straight line, but translation means motion where the orientation does not change. मतलब जो ऊपर है वो ऊपर रहेगा, जो नीचे है नीचे रहेगा, है ना. इसको हमने फिजिकली घुमाया नहीं है, सिर को नीचे नहीं लाया, सिर ऊपर ही है बंदे का. ठीक, that's the idea behind translation. Okay, so one of the most important statements we have in vectors is the fact that the vector can be translated without changing it. Vector को तुम हमेशा इधर उधर slide कर सकते हो and it will still be the same vector. And very nice, वो wheel cabin is part of something, that wheel is rotating, वो सही है, the cabin is translating. And these are different bodies doing different things. The wheel was rotating, wheel घूम रहा है, but the cabin is translating. Wheel में if you color one spoke, you will see that spoke is going to later be here, it's going to be here. So the wheel is definitely rotating like a clock, but the cabin is translating. You are translating, because for you what is up stays up. Okay, and one of you saying, is every linear motion translation? Again, every linear motion for a point size object can be translation, but जैसे आगे सोच सकते हो, if a disk was rolling, we don't need to get into the full depths of rotation and translation over here, of course. Okay? This is something we'll see over the course of mechanics, but just to say that if a disk was rolling on the ground, you know, then again that would not typically be pure translation, right? Because this is rotating as well. So every linear motion need not be translation. The disk is not sliding forward. If it's rolling, वो घूम घूम के रोल करेगा, है ना, तब उसको प्योर ट्रांसलेशन बोल नहीं सकता. So it's moving along a straight line, it's linear, line के along जा रहा है, but सिर्फ ट्रांसलेट करके नहीं जा रहा है, घूम घूम के भी जा रहा है. Okay, so again the only idea behind this discussion is to just expose you to the term translation. Make sure you understand what translation means. More examples in the distinction between translation and rotational you'll understand over the course of mechanics. फिलहाल यहाँ पे बस एक चीज मन में बिठाना था कि तुम वेक्टर को ट्रांसलेट कर सकते हो विदाउट चेंजिंग द वेक्टर. वेक्टर को जिधर प्लेस किया उससे ज्यादा फर्क नहीं पड़ता है, इधर उधर प्लेस कर सकते हो. ओके, डन विद दैट पेज. नोबडी सेइंग वेट. Yes, this is the same as यहाँ पे लिखा है parallel shifting. So the vector can be moved parallel to itself. It moved मतलब shifted, can be shifted parallel to itself, and in doing so the vector will not be changed. ठीक है, इसको उठा के इधर डाल दो. Parallelly shift किया है, parallelly shift किया है, ठीक है, and in doing so the vector is not changed. फंडा ये है, तुम उसको कैसे भी मूव करो, as long as you don't change the magnitude and direction, vector change नहीं होगा. डायरेक्शन वही रखो, मैग्नीट्यूड चेंज मत करो, वेक्टर वही रहेगा. ओके, अच्छा. अब नाउ दिस इज वन वेरी इंपॉर्टेंट सेक्शन. I'm just going to hide a little bit of this. Yeah, अब ये सेक्शन बहुत इंपॉर्टेंट है. What does this section say? This is now finding the, I'll zoom in a bit. ठीक है, angle between vectors. ये और क्यों आया, और हटा देता हूँ. The angle between vectors is the angle you see. I think or was supposed to be it. It is the angle you see when the two vectors are joined tail to tail. You know, angle between vectors का definition क्या है? It is the angle you see when they are joined tail to tail. अब मैंने एक example दिया है. जैसे मान लो मेरे पास ये vector है a बार और ये vector है b बार. ठीक है, मुझे इनके बीच में angle निकालना है. So how will I not? Now remember, you have to join them. So how do you join vectors? You can, without any hesitation, move the vector. So let's move this guy. You can move this vector parallel to itself. So as I move it and I join vector B with vector A, I seem to have two options. One option is placing the vector over here. यहाँ पे the joint is tail to tail. The other option is placing the vector over here. Okay, this joint is, as you can see, this way is head to tail. This way is tail to tail. The other way is head to tail. है ना? Now तुम्हें कौन सा यूज करना है? तुम्हें tail to tail यूज करना है. If you can see, based on what you pick, you will see different angles between the vectors. जैसे ये वाला एक बार देख लो. Head to tail के केस में क्या एंगल लग रहा है इनके बीच में? What is the angle you see? It looks like it's 60, है ना? 180 minus 120, है ना? Tail to tail में looks like it is 60. So that is not the angle you report. The angle you have to report is this one. When you join them, sorry, head to tail में looks like it's 60. Tail to tail join कर लो. That is the angle you have to report. So that angle is going to be 120 degrees. Okay? So whenever you want to find the angle between vectors, slide one, join it to the other in a tail to tail fashion. तब जो angle दिखता है वो तुम्हारा angle between vectors है. That's a very specific term. ये angle 60 degrees is not the angle between the vectors by the definition. 120 degrees is. Okay? And one of you is, I think that's quite smart. You're asking, can we join them head to head? देखिए theoretically मतलब tail to tail ही कर लो, but head to head also gives you the same answer for your information. जैसे यहाँ पे if you just look at this diagram, तुम्हें क्या लगेगा? What do you think that answer is? Does it look acute? Does it look obtuse? What is the angle between them now? Definitely looks obtuse, है ना? And you can prove by parallel lines that that angle is actually 120 degrees. है ना? कुछ alternate angles वगैरह use करके you can say कि that angle is the same. So actually head to head भी चलेगा. एक याद करो, tail to tail कर लो, but फंडा ये है कि tail to tail की जगह head to head भी चलेगा. Head to head भी चलेगा. So that's the idea. So angle between A bar and B bar is 120 degrees. Why? Because when I join them in this fashion, when I join them tail to tail, that is the angle I see. That is the angle I see. ठीक है? इसमें क्या होता है? ये भी चलेगा. This also represents the same thing. है ना? The bigger angle is also technically correct. 240 degrees भी. That is also the angle you see when they are joined tail to tail. The only thing is, if you have to report one answer, people normally prefer the smaller answer. 120 degrees is what is normally reported. Nonetheless, है ना, if 120 degrees is not in the options, but 240 degrees is in the options, you'll go for 240 degrees. Because that is also fine. That's also the angle you see when they are joined tail to tail. 120 is the more correct answer, but अगर 240 है वो भी चलेगा. क्या नहीं चलेगा? 60 degrees नहीं चलेगा. Because 60 degrees आ रहा था जब when they were not joined tail to tail. ठीक है? तो एक क्वेश्चन कर लो, यहाँ पे मैंने नीचे ड्रॉ किया, ये बता दो यार इस एग्जांपल में क्या एंगल है? नहीं नहीं सही है गिरीश, तैनात. Yeah, very nice. I think all of you are answering correctly. Yes, anyone who's answered has answered correctly. Correct. Okay, simple. In this case, the angle is, it's not 30, है ना? Although it's right there. ठीक है, आलस मत कर लो, उधर ही है, दिख रहा है 30 है, थोड़ा एफर्ट यूज कर लो. This is not your answer. This can never be your answer for angle between vectors. Why? They're joined head to tail. Okay. एक second. What is written before A bar over A? अच्छा, A over bar की जगह short में A bar B bar भी बोल सकते हो. What is written over A bar and B bar? अच्छा, okay, this. अरे, this is So this is a shortcut. This actually, this stands for angle, and this stands for between. So if you ever see me write B/W, B/W means between. Okay, so angle between. Angle between. हाँ, इसमें क्या है? The angle between A bar and B bar in this example has to be 150 degrees. क्यों? First and foremost, I acknowledge that the angle between A bar and B bar is not 30 degrees because they were joined head to tail. That's not your answer. What you need to do is you need to slide one of the vectors. Like for instance, I slid vector A bar. Vector A bar को उठा के मैंने यहाँ पे आगे slide किया, आगे push किया, आगे बनाया. ठीक है? तो वेक्टर ए बार को मैंने इधर ड्रॉ किया, और जब वेक्टर ए बार को इधर हमने बनाया तब हमें दिख रहा है कि एंगल बिटवीन ए बार एंड बी बार is 180 minus 30 is 150 degrees, and this is the answer because this time they're joined tail to tail. ये वही simple, वही simple. हेड टू टेल वाला जो आंसर है उसका सप्लीमेंट्री एंगल, इसको आगे स्लाइड किया, जो बचा हुआ एंगल दिख गया 150 degrees. That's actually the angle between A bar and B bar. Simple. Remember this term. This is simple, but this is, I think, ignoring this causes a lot of mistakes, silly mistakes from students. So remember this. Yeah, that's why I star mark this specifically. Yeah, let me know if you still want me to wait. Some are done. Can you please give another example? Yes, that's. Hey, got example. Yeah, I'll wait. Another example in the meanwhile, yeah. क्या होगा इसके बीच में एंगल? ये दो वेक्टर्स के बीच में एंगल क्या होगा? सिंपल है ना? यस, करेक्ट. So it gets quite simple. इसको just ऐसा move कर लो. It's okay if you can't do that. You can just draw the same thing again. Move करा लिया. Move कराने के बाद ये जो angle दिखता है, that is our answer. Join them. Move one vector. Join them such that the tails are joined, and then the angle that you see between them is the angle between the vectors. So 135 degrees would be the answer, and 45 degrees would not be the answer. Got it? Okay, now done. Whoever said wait. Now are you done with this page? Okay. Then now two important conditions when the vectors are parallel. Okay? So angle between parallel vectors is going to be 0. कैसे? क्या logic है? जो दो parallel vector को तुम जब join करोगे tail to tail, they're going to look like this. Alright, so they are in a way overlapping. It's like it's like the needles of your clock at 12 o'clock, right? The hour hand and the minute hand overlap. वैसे ही है. They are overlapping. So in that case, what is the angle you see between them? It's this small angle. It's in fact as good as 0. So the angle between parallel vectors is 0 degrees. On the other hand, the angle between opposite vectors, or the angle between anti-parallel, remember that word. The word anti-parallel means opposite of parallel. So anti-parallel means opposite direction वाले vectors, उनके बीच में angle has to be 180 degrees, because wherever those vectors are, the minute I join them tail to tail, they're going to look like this. 6 o'clock कैसा दिखता है वैसा. They're going to look like this. All right, so the angle between them when the tails are joined, that's going to be 180 degrees. So anti-parallel vectors के बीच में 180 degrees angle होता है, parallel vectors के बीच में 0 degree angle होता है. Okay. Anti-parallel opposite vectors के बीच में 180 degrees, parallel vectors के बीच में 0 degrees. Easy to get that. Doubt है तो पूछ लो. And let me know if you want me to wait. Waiting. Waiting. होने पे बता दो. नहीं, if the angle is anything else, we will not call it anti-parallel. ठीक है, ऐसा obtuse angle दिखा उसको anti-parallel नहीं बोलेंगे. Anti-parallel is a very specific term. Anti-parallel means exactly opposite. वो 180 का 179 भी हुआ ना तो भी anti-parallel नहीं बोलेंगे. Yeah, they should, है ना, when you join them, it should look exactly straight. They should be in exact opposite directions. East, west, वैसा. Left, right, exact opposite, तभी anti-parallel होगा. और कोई भी केस obtuse angle होने दो, acute होने दो, you're not going to call them parallel or anti-parallel. Just like you will not call 30 degrees angle as parallel vectors, वैसे you'll not call, है ना, 120 degrees, 150 degrees as anti-parallel vectors. It has to be exactly 180. ठीक है? Yes, 0 is also the same as 360. Nobody normally says 360, but you need to understand that they are fundamentally the same. 0 degrees, of course, what people will normally say. But fundamentally, if I, you know, say I took a, have you ever heard a lot of people sometimes they say my life took a 360-degree turn? I think they don't know basic math. When 360-degree turn is nothing. You're back where you were heading. Technically, people should say my life took a 180-degree turn. If that's what they're trying to say. If they change the ways, you took a 180-degree turn. It's funny to hear people say 360-degree turn because that means no change at all. All right. You catch a person the next time they say, I took a 360-degree turn. All right. So with that, I think now we're ready to see how to add vectors. We're actually ready to see how to add vectors. So we are going to add vectors. As I said, this is like a new physical quantity. We cannot add vectors the way we used to add numbers. 3 apples plus 8 apples is 11 apples. यहाँ पे 3 plus 8 is 11 easily कर नहीं सकते. ठीक है? So this is a new physical quantity जिसके लिए we're going to learn some new maths. And that new maths that we're going to learn, we're going to call that as vector algebra. We'll learn how to add vectors, subtract vectors, and so on. Okay, so starting with how to add vectors, we have this law called as the triangle law of vector addition. अब इसका process क्या होता है? ठीक है, these are the steps. The first step tells us to join the two vectors we want to add in a head to tail fashion. मतलब एक का हेड दूसरे के टेल पे डाल दो. It does not matter किसका हेड किस पे टेल पे जा रहा है. If it would have mattered, they would have told you किसका हेड किसके टेल पे जाना है. But since we have not told you, the whole idea is it does not matter. कोई भी एक वेक्टर को स्लाइड करो और उसका हेड दूसरे के टेल पे डाल दो. That's the first step. First step. Second step is complete the triangle. Complete the third side of the triangle by drawing a vector from the available tail to the available head. let's stop over here and let's see what this means so far. Okay, available tail to the available head. So let's say in this example I want to add these two vectors, 3 Newton upward, 3 Newton towards the right. तो हम पहले क्या करेंगे, we will join them head to tail. So you can either move this guy and put the tail of B bar at the head of A bar, or you can do it the other way around. You can put the head of A bar at the tail of B bar. Okay, whichever way you do it, you're going to get a diagram like this. Okay, so मैंने in fact यहाँ पे क्या किया, I've taken the head of A bar and I've put it at the tail of B bar. I have a feeling मैंने थोड़ा उल्टा बोल दिया, sorry. I think I ultimately said the same thing. या तो B बार का टेल A बार के सिर पे डाल दो, वो एक ऑप्शन है, या दूसरा ऑप्शन होगा A बार का टेल B बार के सिर पे डाल दो, वो दूसरा ऑप्शन है. ठीक है, वो दूसरा ऑप्शन है. Whichever way you do it, you'll get the same result. या तो A बार का टेल B बार के सिर पे डाल दो, या B बार का टेल A बार के सिर पे डाल दो. ठीक है, so I've done the second one. I've put B bar's tail on A bar's head. When I do that, when I put B bar's tail on A bar's head, and I've drawn the vectors, so this is something of length, I mean the magnitude of the two vectors is 3 and 3. ये draw करने के बाद the next thing I do is I'm going to complete the third side. So फिलहाल उनको join करने में ऐसा दिख रहा है, दो yellow vector दिख रहा है. I'll now complete the third side, okay, by drawing a vector from the available tail to the available head. Now, what is the available tail in this diagram? What is the available tail? This was, yeah, A ka tip was the available tail. And before I draw the third side, this is the available tail. ये खाली पड़ा है. That is the available head. वो खाली पड़ा है. So how do I draw the third side? I'm going to draw a vector from the available tail to the available head. Okay, that's the third side of the triangle. Available tail, A का tail से B का सिर. B का tail available नहीं है because B का tail A के सिर से joint है. A का tail available था, B का head available है. A के tail से B के head तक we have drawn the third side. This third side which we just drew, okay, now suddenly this is like a vector. This vector that we have just drawn, that will be the addition of the two vectors. खत्म. मतलब वो बोल रहा है कि ये जो हमने ड्रॉ किए हैं वो इन दोनों वेक्टर का एडिशन है, वो ये दो वेक्टर का एडिशन है. एंड और क्या बोला है, they are saying कि this is called as resultant. ठीक है, so addition of two vectors is called as the resultant of two vectors. So resultant is another word for addition. ठीक है, what you get when you add the two vectors, उसको एक नाम देते हैं, and that name is resultant. ठीक है, that's the result of these two vectors in that sense. So therefore it's called as the resultant of those two vectors. Were you expecting this? फिलहाल कि मतलब ऐसा एक upward and rightward vector, ये दो force को जब club करोगे, were you expecting to see a vector go in that direction? नहीं. No, मतलब forget about the procedure. Weren't you expecting कि तुम upward push करोगे और right की तरफ push करोगे तो net effect ऐसा कुछ होगा? Expected था ना, थोड़ा ऊपर की तरफ थोड़ा right की तरफ ऐसा net effect आएगा. A little bit, okay. Hey, think about it. Imagine you're trying to push a car. One person is pushing the car like this, another person is pushing the car like this. Which direction will the car go? Won't it move in that direction? Won't it move in that direction? Okay, so that was something which we are in a way logically expecting. Now I'll explain how I got the angle, how I got the magnitude. So देखो angle कैसे निकाला, magnitude कैसे निकाला. पहले तो magnitude निकालने के लिए ये तो एक right angle triangle दिख रहा है मुझे. हाँ, yes गिरीश, अभी ये राइट एंगल ट्राइंगल दिख रहा है. राइट एंगल ट्राइंगल का ये फिर हाइपोटेनस हो गया. मतलब मुझे क्या लगाना पड़ेगा, पाइथागोरस थ्योरम है ना. तो पाइथागोरस थ्योरम से मुझे ये तीसरा साइड मिलेगा. तो क्या पाइथागोरस थ्योरम क्या बताएगा, थर्ड साइड शुड बी रूट ऑफ 3 स्क्वायर प्लस 3 स्क्वायर. root of 3 square plus 3 square becomes root of 3 square into 2, because there are two such terms, and 3 square को बाहर ले लो 3 आ जाएगा and root of 2 रह जाएगा. तो क्या मिल गया मुझे? 3 root 2 मिल गया. पाइथागोरस थ्योरम से क्या मिल गया मुझे? 3 root 2 मिल गया. Is everyone clear with the magnitude? कैसे थर्ड साइड का मैग्नीट्यूड 3 root 2 आ रहा है with, I mean by applying Pythagoras theorem. Okay, all right. The other thing is, how do I know the angle? Yeah, magnitude is 3 root 2 Newton. You're right. Magnitude is not just the number, it's the number with the unit. So magnitude is 3 root 2 Newton. Correct. And फिर about the angle. So if you just look at this, this is a right angle isosceles triangle. है ना? One angle is already 90. दूसरी बात ये है कि ये दो sides बराबर है in magnitude. So if the sides are equal in magnitude, side के opposite angles also are going to be equal in magnitude. मतलब ये वाला angle और वो वाला angle दोनों बराबर होना चाहिए था. अगर दोनों बराबर होंगे और दोनों का सम वैसे कितना होना चाहिए, यहाँ पे ऑलरेडी 90 चला गया है, तो फिर इन दोनों का सम 90 होना चाहिए, बिकॉज टोटल 180 होना चाहिए. सो दीज टू आर द सेम एंड बोथ ऑफ देम ऐड टू 90, मतलब बोथ द एंगल्स शुड बी 45 45, है ना? बोथ द एंगल्स शुड बी 45 45. Okay, why are both 45? एक सेकेंड, एक सेकेंड. Yes, if AM, the reason this is in Newton is because these two guys are given in Newton, of course. Oh, hey, that's there. In these two are in Newton, so the third side is also in Newton. That's of course there. Then why are both 45? I'll explain that again. And one of you saying if the magnitude of one vector is more, the resultant will be in the direction of, it will not exactly be in the direction. तुम थोड़ा logically सोचो, अगर एक दूसरे से ज्यादा है, the resultant का direction will be in a way you'll expect it to be closer to the greater magnitude, and that's also something we'll see as we थोड़ा और आगे examples देखेंगे. It will be closer to the one with greater magnitude. Exact वो direction में नहीं होगा. And we are going to do, we'll venture towards questions where the angle is not 90 degrees. Okay. Yes, Girish. एक बार let me establish why this was 45 again. देखो ये 90 है, ये 3 and 3 है, मतलब ये angles बराबर होने चाहिए. Do you see that? है ना? Opposite equal sides, you have equal angles. Okay, so these angles should be equal. फिर we know कि total sum has to be 180. मतलब 90 degrees plus theta has to be 180 degrees. है ना? तो यहाँ से समझ में आता है कि 2 theta has to be 90. If 2 theta has to be 90, theta has to be 45. Got it? Theta has to be 45. So what is our answer? When we get A and B, our resultant is this. Okay. So while talking about a resultant, it is not just enough to say 3 root 2 Newton, but we also need to find out the direction. So it seems like it's 3 root 2 Newton at some angle of 45 degrees with the vertical. वो magnitude भी निकालना है और direction भी निकाल के रखना है. और सामने फिर ऑप्शंस पढ़ के तुम सही ऑप्शन पिक करोगे. ऑप्शन ऐसा रहेगा कि 3 root 2 along an angle of 45 degrees, making an angle of 45 degrees with the vertical. So the option will write it out in words. But you at least while solving need to solve it till a point where you know what the resultant's magnitude is and what its direction looks like. Okay, this was one example. We'll do more examples. But ये समझ में आया? ठीक है, यस ओके, आगे थोड़े और एग्जांपल्स हैं and I'll actually go over some basic triangles with you guys. So actually वो जो हमने वो जो देखा ना, जो अभी अभी बनाया 3 3 एंड फिर तीसरा साइड 3√2 आया, that's actually a very standard triangle जिसके angles are always 90 45 45. So ऐसे there are I believe four standard triangles. Third one, yeah, there are four standard triangles. So in the next class, which I think is tomorrow itself, you know, we'll go over those four triangles as well. Okay? So again, so far no homework. We still, at least we need to learn how to at least add vectors. So once we are able to add vectors, then that'll open up the space for some substantial homework. Okay? So just take it easy, stay safe. Just revise whatever just revise triangles, this last thing, and come. Those who have not yet, those who missed the first lecture, those who join new, please take out the time to watch the lecture recording today itself of the first lecture. If you missed the first lecture, watch the lecture recording. I hope you were able to cover up and understand what we did today. This is the link. One last time, just copy that somewhere. Okay? Or you can even ask your center managers for it. Copy that somewhere. And when you open the first link, okay, linked to lecture recording is the first link. That's going to take you to a place which looks like this. Open vectors, open 21, 23. That's that's the year you're joining and the year you'll be leaving. Open Med 1 and watch that lecture if you have not watched it before. If you didn't attend the first one, watch that lecture. Okay? The last time the notes you'll open the second link. You open the second link, open vectors, open part 1. Yeah, part 1 abhi start kiya to part 1 mein rahenge, and that's it. All the notes that we will be doing will be uploaded. Okay, cool. What are we saying? This week's lectures have increased. Next week और बढ़ेगा क्या? I mean और बढ़े पता नहीं, और हो सकता है बढ़े, but I think your timetable seems a little full right now already. Your first week, of course, was very light. That was your first week, but maybe the way it looks now is how it's going to be आगे जाके भी. So enjoy these few initial days, and just because eventually it's going to be lectures almost every day. हो सकता है 1-2 दिन छुट्टी हो, but that's how it's going to be the next 2 years. So just use these next few days to refresh yourselves and get ready for what lies ahead. Okay, and stay safe. So bye. Welcome. Bye. Welcome. Bye. Welcome. Bye. Okay. Bye. Bye.